Thank you. Well, good morning, everyone. So this track is on FIDO, and it was structured in 4 parts, and each part is looking after a different objectives of why we use FIDO. So there is a story we're trying to do today. So in the morning, what we want to focus on that the traditional multi-factor authentication is not really good enough to protect the consumer at the end of the day. So what we want to show is how MFA work, and the issues with MFA. We'll take a real life example that most companies have to deal with, which is account takeover. And if account takeover happens, we should have a process to address it, and it has to go both ways, from the end user and from the consumer. Plus, there are some rules and regulations that you have to meet in order to inform the users. So it's really a sophisticated process that needs to be addressed, and it needs to be used. So we build the case that MFA on its own is not good enough, but you need stronger authentication like what FIDO offer. But also, since you have legacy systems and other type of issues that you have to deal with, so there is a need for risk-based authentications. So this is what we do with the first session. The session after that, we introduce what FIDO is about, and we show use cases of how FIDO will be used. And that one will be between me and Amy. And the examples that we will be using, they are real life examples. We are showing you what CVS does to implement and deploy FIDO. So this is FIDO in action. It's not theoretical, it's in practice, it's being used, it's being deployed, and it's protecting people as we speak. On session number 3, Ralph from Knock Knock Labs. And by the way, if you have any questions on FIDO 2, ask Ralph. He is creator/author and inventor, whatever you want to call it. So this technology started by Ralph and Knock Knock Labs, and it became mainstream. So we will talk about needs for interoperability and also need of change when it comes to certification and auditors, and what is required for FIDO to be adopted mainstream. So to ensure that we have a systematic way of presenting FIDO to meet all criteria of accreditation, there is a certification program that the FIDO Alliance have done. So we have multiple levels of certification. We certify the deployment of FIDO by itself at different levels of assurance certification. Plus, we certify the biometric entity that's used to be for authentication. The reason for that is if you look at the NIST 863 series, NIST tell you there is different assurance level from the identity vetting to the authentication assurance. So for those agencies that need to meet a certain criteria, there should be a way to know what is the assurance level or the reliability of the actual module that's performing authentication. If you're doing fingerprint authentication or any biometric authentication, you have to know the false acceptance rate and the false rejection rate. And someone need to be able to judge those. A lot of the manufacturer print numbers, but these numbers need to be verified. So FIDO also has a program that do biometric certification, and for the main reason that we want to certify that a given hardware module meet the criteria or the claims that that module does. So Ralph will look into that in session 3. I'll start by a small introduction in that session to saying why we need that certification. Okay. The last session, we have George from Accepto. Accepto is one of the vendors that work with CVS, and what they do FIDO implementation, but also they do risk-based authentication. So they are the supplier of our risk engine. And George will go over the use cases and how the risk-based authentication will be used in combination of FIDO and in real life. One thing I did mention yesterday, if you were in the session, we did not just want to talk about FIDO when we work with the ITU. We said that we need to have an endpoint where people that really want to test this technology can write code against. So within the ITU, there is an endpoint that is it has FIDO in it. There are sample code and sample mobile app. Anyone is more than welcome to use it, to test it, to kick around FIDO if you want to deploy it in your company or in your country. So George will be going over examples of that endpoint, so you can have hands-on experience and actual real-life deployment. So this will be the last session. It will be use cases and actual implementation. So any questions about how the day will go? And we're flexible because we can run a little bit shorter or longer. So if you want anything added, if you have any questions that we're not addressing, you can ask and we'll try to accommodate you. So are we okay to go? So far so good? Okay. So my name is Abbie and I work for CVS, and I'll be doing this session with George from Accepto. I don't know why your name is not on the slides, but you can introduce yourself, George.
I'm George Coelho. I'm a developer for Accepto. I am responsible for our FIDO2 SDK for iOS. And today I will be talking a bit about our RPA solution, our Cognitive Continuous Authentication solution. And in the end of the day, I will basically demonstrate how when you have an iOS application just with username and password login system, how you can easily use the FIDO SDK and ITU's FIDO server to insert insert FIDO authentication in your own system. And that's it.
Thank you. Okay, so account takeover. Anyone here can define account takeover? Let's do it interaction so we get involved. So what's account takeover? If you are a user or a consumer, have any one of you experienced that their account has been taken over? No one? You try to go to log on to your bank account and you cannot log on, they tell you your own password, but someone already logged on into your account and changed your password. So basically account takeover, when someone take the control of an existing account which is not the legitimate user. Someone will just get your credentials and will go ahead and do a password change and change the password on you, and now you want to come back to your account and you cannot get it. You may think it's not really a serious problem, but you can ask Amy about the nightmare you have to go through. With CVS, just to tell you a little bit how much we need to deal with. We are the third largest company in the US. We are top 3. Number of account users we actually serve is about 180 million Americans. Multiply on the average 4 accounts per user. It's a nightmare. Most users, when they use passwords, they will have the same password across different accounts, because users they cannot remember too many passwords. All the problems with passwords, it's real. People reuse the passwords, they use a very simple password. And if you break into one account for one given user, most probably you can go ahead and break into all of their accounts. So many sites you go to, they ask put the user ID. So most of us, what do? We put our email address. It's very convenient. You put your email address as your user ID, and after that, the password. If you're using your password and I'm a hacker, what's going to happen? If I broke into your email address and then I saw that you have emails from CVS, you have emails from Bank of America, you have emails from JP Morgan, most probably your user ID with that institution is your email address. So to get the username password combination, I already have 50% of the guess needed to break into your credential. I know your logon most probably is your email address. Why we allow you to do email address? Because in the older days, you had to remember your logon ID, and then you had to remember your logon password. So a lot of the people start using the email address as your logon ID. There is a pros and cons. Like for strict security reasons, I should not allow you to use your email as your ID. But for user convenience, you have to allow that because most users will remember their email address. So this is why risk-based authentication come into the equation, as later. This is why just a combination or successful logon is not good enough when you want to protect an account. So the issue here is if you lose or somebody hack a credential and they try and it gets into wrong hands, it's very easy to break into user accounts. It's not that hard because they do a hacker will just ship that information, get sold on the black market, and then you could do drive-by attacks where you use the same name, username and password across multiple institutions, and in no time your accounts are broken across multiple organizations. So why users do that? It's an older account has much more value than a new account because an older account is an established account. It has history. So if I take over an account that's an old account, it's most probably a trusted account. So if I want to use it for the bad usage, I don't want to create a brand new account where the account is fresh and try to go do a financial transaction or try to, from it to launch other attacks, okay? An older mature email address is most probably has been labeled clean by agencies that do monitoring of you. Who are these? Experian, Ideology, LexisNexis, all those credit agencies that look around. If they have seen your account before, this account is associated with your phone bill, with your electric bill, there is a payment history with that account is a trusted account in current way of doing business, and it's broken. This is why the knowledge-based economy, we're trying to really kill it. We could talk later on what we're doing within the US, all the way from the Congress to the Senate. We have a whole kind of strategy to put the proper rules to change this. In the older days, it worked because the whole, at least in the US, the whole system was based on social security number that was supposed to be secret. Nowadays, it's not secret, it's public. So the credit reporting, the credit agencies collected information about you and put it in correlation to your social security number that quote unquote was supposed to be secret, and it used to be to give trust in your anchor. This was a pre-mobile world, pre-digital ID. It used to work. Now this information does not help me as a consumer, it actually hurt me. So we need to change it from the core, and we have a whole program that addresses that core issue at the legislation level. Okay, so this is another story, but at the end of the day, this is part of the problem why older accounts are much more valuable than newer accounts. So hackers will, plus nowadays with the credit cards, in the older days you could go ahead and steal a credit card and use it online. It was easy till the next cycle happen where the credit card get like stopped before it get the credit company. Now with the way the payment system work, if a credit card is stolen or lost, we can it can be stopped by your bank immediately. Actually, you have the on-off lock button now, because you can stop it if you misplace your card. If you find that you can do it, because the payment system is more now dynamic, not static. So you could validate that the credit card is good or bad before, quickly. So, so if you steal a credit card, the lifespan of it is short, especially for online. If you steal the credential of a good account, old account, the lifespan of the theft and the fraud is longer. So, because at the end of the day, if the end user does not discover that their account has been taken over, the account is good account. Plus, you could go into the account and steal good data from user profile and other information in it. So now, how we lose an account? Multiple ways to lose an account. Phishing. All of us knows what phishing is. You get an email, your bank has been deposited some money to it, and you get the email with very good look and feel like it's coming from Bank of America or JP Morgan. And people click on the link. The link takes you to the hacker site that looks like Bank of America, and you enter your credentials. If you're using a password, at the moment you go to that website and you enter your password, what's the probability that your account is taken over? It's 1. At the moment you go to the phishing site and you click, you enter your credentials, someone is waiting for you. That's it, your account is taken over. They do a relay. You put your username and your password, they get logged on into your real account, and then they do a password change. The password change, even if the bank is sending you an SMS, you're expecting an SMS to come to you. So you enter the SMS, the hacker get the SMS, the OTP on the SMS, and relay it back to the bank site. And the account has been changed. That's it. So MFA in today that everyone issue you go to their site, an OTP sent to your phone by SMS is really not good. It's not going to stop it. And the reason is there is no mutual authentication between two endpoints. There isn't. If you do mutual authentication between two endpoints, you know that I'm calling you and you're calling me. But as long as you are sending out without coming back, I'm getting that phone number and it's on the side channel, it's not going to happen. It's broken. Other ways you get to lose your account is if you have malware, Trojan horse, spyware. If someone installed malware on your computer or on your machine and they have a keylogger, that's it, your account is taken over. Also, social engineering. Today is like, my wife yesterday was telling me she has got about 7 calls from Revenue Canada saying that they're gonna suspend her social security number if she does not log on. That's the scam. And a lot of the, actually, like last year in Canada, about $8 million were lost to these spammers because the older population that's not aware of the scams, they went and they bought the credit cards and paid the hacker with a credit card. This is how the scam was. Send us money. How would we send you money? Go buy those chargeable Visa cards, fill it in, and yeah, and older people are targets. So this is, like real life pain, and it happened. And you cannot. The social engineering works, and there are real life victims out of it. You have a lot of stories of people especially older people, that have lost all of their life savings for spammers and hackers. One family lost $100,000 because that was going for a long time, So, it's real and it's threatening. So from our end, especially if you work in companies that have sensitive data, like on the black market, the health data is the most expensive data, your health data, because it's much more detailed and it has a lot of value on it. So taking over an account from our end pays good money. So it's we have to prevent it. So account takeover is a threat. threat to everybody, and there is a reputational damage. Once you lose your account as an institution, your reputation go bad, and then the trust between you and the customer go bad. And the way the system works today, everything is stacked against you because there are so many weak points. The consumer, if they are reusing a password, and as I told you, 50% of the guessing game is already taken, because if your logon ID is your email, it means I know your logon ID. I don't need to figure it out. I know your logon ID. If you go to one site that, and use your email and a simple password, and then that site get hacked, I pay the price because the user used the same information. So the hackers will target when you have data breaches. Hackers do not come to us. They try, but we have more money and better ability to defend ourselves. But they will go to a cheaper operation with not too much security, and they steal that database and use those credentials to massively come in and attack us because users do not protect themselves really well. So, I did talk a lot about what's in this slide. So richer data has a lot of value. Older accounts are richer data accounts. There is a history, so they are a target, okay? So credential stuffing is one of the big techniques that is used to take over an account, okay? So any idea what's credential stuffing? I've been saying what's credential stuffing all the time. It's basically, I get your username, password, I go to every site and I try that username and password. If it's your email address and your password, I just blindly go with automated script, every bank, hit every pharmacy, and see what happens. 90% of the time you will get in because users use. So, if you lost a username password combination that is valid, you're done because it takes no time for an agent to automatically do it. It's automated. The hacker only get involved when there is a good result. There is a hit. We broke into one account. This is where they start doing manual work. But automation is the key to their job. They only get involved when there is a hit. So credential stuffing works. It really works. Why it does work? The alternative to credential stuffing is to go to a site and try some user ID and some guest password, same user ID, another password, depending on the type of the error the site does. In the older days, the site used to tell you wrong user ID. And then I remember about 10 years ago when we were doing our identity management work, we said to everybody, stop telling the hacker where they succeeded. So you could see today when you log on, it tells you either your username or your password are wrong. But we worked on this actually because that was the worst. That is what was one of our recommendations. When you tell the hacker that the user ID is wrong, it means try a better user ID. When you tell the hacker it's either the username or the password, the hacker does not know which one worked, right? So you do not give more information on a website to help the hacker. Stop doing that. That was part of 1205 that we did this in 2006. This is stop doing that. So X.1205 is the cybersecurity recommendation. Actually, it defines what cybersecurity is. And we did this when I was chairing the cybersecurity question in the ITU. So this done happen. So what was the credential stuffing came as a response? Because, every user started having multiple user ID on a website, and then it became a nightmare. So we defaulted to having your email. So now we're back to square one. So credential stuffing take a known user ID, most probably it's across all, and do like mass shooting, shoot, whatever get to work, it's fine. And the hit ratio is very well. It's very good. So credential stuffing is real and it's serious, and it's, you know, it does work. A brute force nowadays does not work. Why brute force does not work? Because of rate limiting. 3 times you log on within 1 hour to our site with the wrong username password, what do? We lock your account. And we lock it for 1 hour. You do another thing, we lock it for a whole day. And then you cannot come back till you call the call center. So the hacker has to go through another loop. What we do is it's called friction. You do friction to slow the hacker. So they say friction, it means you let the hacker work more. Hackers do not really want to work. They just want to get into the account. The amount of work that they need to do to get into an account, it has to be minimal, because they get paid by how many accounts they hack into. Okay, and if you hack into account, you still have to do the work by stealing the data or reselling the account. So the less amount of work they do, the better off they are. So that said, you know, a brute force is not a very good approach. But there are ways around that, because, you know, if you steal a database of password hashes, you are in trouble, because do you know what rainbow tables are? Yeah, so with rainbow tables, you could do reverse engineering to every possible password, you know, even if it is salted or hashed, especially like you could do that 1 per 20 seconds. We can crack a password on the average 1 per 20 seconds. So, you know, even if we use even with salting, yeah. Because the table, it's like a binary tree, you just zoom in between, and there is enough history to where somebody have done the lookup before, so you don't have to work from scratch, you know. So it's AI. Actually, our worst enemy now in authentication is AI, because you could train an AI system to break into any authentication system, because you're doing data manipulation. Okay, so. Okay, so we have covered a lot of what, you know, with what credential stuffing here. So I have it here in, you know, you have a server that's compromised, and you get a credential. You know, Joe has password as ABC, Sue has password 1, Bob has another password, and then you blast that password and username combination to all other sites till you get a hit. And credential stuffing really work. Any questions so far?
So using of single sign-on, is it a good approach?
Single sign-on is even worse. Single sign-on is convenient, but does not mean it's secure. Why single sign-on is, from my end, my worst nightmare is single sign-on. Because you see, like, I'll give you an example, and Amy have to deal with this almost every day. We have an application called Payflex. Payflex does handle money. It has access to your HSA money, right? HSA. So you have a Navigator or Aetna Health is at the front. There is single sign-on ability. So maybe Payflex, when you want to go to your account, it has much higher security. But for convenience, if you come into your Aetna Navigator account, you could single sign on to the other. So if the log-on criteria to Aetna Navigator is lower, less strict than the Payflex, how you think hackers will go to Payflex? They're not going to come into your account in Payflex. They're going to come into your account at Navigator, because you're doing single sign-on, and who's the weakest account is that account. Because why sometimes you need to do it this way? You need to do it this way because the amount of services at Atna or Navigator, we give you stuff that may not be PII or very risky. But later, the business requirements say, well, now the user logged on here, we're not going to ask them to log out and then to go back to their money. You need to single sign on. In the older school days, you could just single sign on, and then hacker will always figure out, this is the weak point, go through here, go single sign on to an account with a higher assurance level. So now what we don't allow that. What you do, you have to step up to go to the PayFlex account. You have to go and meet the requirement. So a single sign on, if it is not designed properly, it's a nightmare, because the idea here is you will join account and have a single sign on, and if it's designed wrongly, you will use the least secure account to sign to the higher secure account. So it's a problem, and we need to make sure for when it's convenience, but the security policy is consistent for the accounts. So this is why you need also another example of risk-based authentication. That's why you need stepping up. Because if the policy say this access point require higher assurance level, you're going to have to step up to that required application assurance level. Yes.
Okay. Thank you. I wanted to ask about when we try to do authentication using like jump servers. Does it solve problem?
What service?
Like the jump server, like, okay, when you're authenticating maybe from this computer, there is a way that the credentials are saved offline.
Mm-hmm.
So there is a probability that you use this computer to log into another server. That server will be the one to authenticate you.
Oh, you mean a proxy?
Yes.
Yeah, proxy is not. You want to answer that, Ralph? Proxy authentication is usually weaker authentication than the original. Proxy authentication allow man in the middle.
So the main challenge with the proxy is that from an architectural perspective, you can't really distinguish a proxy from a man-in-the-middle attack. Right? So for the relying party, it's pretty difficult to understand whether that server where the authentication comes from is from an attacker or is a legitimate proxy acting on your behalf. That's problem number one. The second problem is it's very difficult for the proxy to understand whether it's really you. And now the proxy essentially has the same authentication problem that the relying party originally had, right? To know whether some computer which comes in is you and has a legitimate right to unlock and use your credential, right? Whereas an attacker could also try to get to that proxy and just try to unlock and misuse your credential. So somehow you are just shifting the problem of authentication from the user and the user's device or the relying party to that proxy. Right? It's not solving the problem, it's shifting the problem just to a different entity. We have a lot of that you see with let's say the tokenization and host card emulation kind of systems, where the only advantage you really get out of that, you convert a long-term credential into a short-term valid credential, which sometimes gives you an advantage. In most cases, I would argue these days are over. Our devices now have much better capabilities, and we should rather use those devices as opposed to creating a big honeypot of nice user credentials, which will be in the focus of most attackers very soon.
Yeah, so I think in some access points, your server or your browser is forced to one endpoint and you authenticate to that endpoint. So in that case, in that specific deployment, you are telling everyone has to go to a known identity. So it could help in solving the problem if you have that endpoint channeling of logon credential to a specific server. So you could do that. I think this is what you were asking also about. I'm not sure.
Yeah, I'm asking that because okay, we are in the same industry of financial services. And like from the Swift perspective, in what they have called the customer security, and I think from the recommendation from the BIS yesterday, they were talking about that. I think there is one control that they are trying to tell the customer to use such technology. So I was trying to understand, as we are in the same industry.
I hear you, but I think this is an B2B, business to business. So it's equivalent if they're saying the authentication server, like you have the endpoint to channel everything to this authentication server. So most probably it's all over VPN. So if you cannot reach the server, you cannot pass the credential. So this is a network type issue. It works in those situations, but it's not addressing the same problem we're addressing here. Okay, because you're doing business to business transactions, so you do channeling. Yeah, so it's a different. No, but I know what you're trying to say. Okay, so I think we covered most of this. Okay, let's go to the next one. Okay, now how can we detect if you are a provider or relying party? How can you detect there is an account takeover? And that's very important, because if someone managed to take over one of my customers' accounts, I should have built-in criteria to let me know there is something happening with this account. So the question is, how can we figure that out? You need this risk-based type of, so you need to monitor. So just having an account, and if you want to be a responsible relying party, you have to have a proper tools to monitor an account after a successful logon happen. A successful logon to an account does not mean it's the legitimate user that logged on into that account. So it's very important for us, you know, like as professionals, to put a life cycle management of an account to make sure that account stays with the proper hand the whole time the account is being used. So how can we detect that an account has been compromised? That's the question. So any ideas, how would we do that? If you are a hacker and you take over an account, what do you want to do?
We delete any login activities, the history of activities.
It's tougher because the logon activity will happen, but because you have to hack into the network to delete the logon activity. So this is tougher. But now I got into your account, okay, and I'm a bad guy. What should I do? The first thing. I need to prevent you from going into your account, right? I want to take it over. So I do maybe a password change. Okay, or I have to start making that account look as if it is mine. If I have, you know, depending what I want to do with the account. At the end of the day, the suspicious activity, it will be, if I'm looking at the account, there is a log on to this account from not a normal IP address. Usually the account is for me, and most of the time I have to I log from Ottawa. So if I'm the bank and I'm looking at Abbie accessing this account, the IP address of the source IP address is in Ottawa. The geolocation of the machine, it's in Ottawa. It's okay. Usually he log on in the morning. So you start building a behavioral profile of how you. When I come in, the first thing I do, I look into my account balance, right? That's what I do to see how much money I have, right? Okay. Yeah, so basically you have a global, the way you look at the account, you look at the global parameters like geolocation, IP address, the type of the machine. I'm not going to buy a different PC every day, even if I have a new phone. Yeah, so the operating system, there is a pattern, you know. Usually, if there is a new device, the device is not coming out of the clear blue. I'm not going to come in with a brand new iPhone and the first time I log on to my bank from Geneva. Most probably I bought the phone at home. So even if there is a new device coming in, it has to be within the natural coordinate of your existing behavior. So this is why risk-based authentication, you cannot not do risk-based authentication. This is why George is here. End of the day, you still, even for successful logon, you have to have a behavioral interaction between the user and the account. So you build that by experience. It takes time to do that. Okay, if I'm a hacker, the first thing I do, I will do a password change. So now, a new IP address, a new geolocation, a new machine, successful log on to the account, and first request is password reset. I should be having alarms on the back end. Stop. It's not right. It's wrong. So what do? I have to do friction. You know, it may be legitimate. You really lost your machine in Geneva. You bought a brand new computer and you need to do a payment. It could be legitimate. It could be you, but it could most probably it's not you. Now, if the IP address is coming from those proxy VPN services where you know their IP range, that's even much more worrisome because I need to check. It means someone is trying to hide behind behind the VPN, the concentrator. Okay, he's trying to fake their origin. So it means me as a company, I have to subscribe to services that can do reverse IP lookup and tell me this is coming from a concentrator. This is coming from a VPN service. So I need to do those checks it's part of this stuff. So you build a profile and then you have to have an action. If things do not match what an expected normal behavior is, you have to do step-up authentication. Step-up authentication is part of risk-based authentication. So you have to have risk-based authentication. There is no way around it. FIDO do a lot of security for you because it does eliminate a lot of the problems, but FIDO does not eliminate the need of risk-based authentication. You always need to have risk-based authentication for the reason that I told you. So this is what one, like what you look for. So. And you do other, like, I have seen this new machine. Remember, with browser fingerprinting, I can know pretty much the browser type, your operating system type. I can know what you're running on, what the browser is running on. So I know pretty much your computer, okay? And you have to have a table on the back end. Is this computer really connected to more than one account? I may be using my machine and I log on for me and for my mom. Actually, I do because my mom never. But that's 2 accounts. If my machine now from my bank is connected to 15 different accounts, what the bank is knowing about my machine? Most probably he's a bad guy, right? So this is another way of doing risk-based authentication. So you have to correlate the machine per account. And if I'm also a bad hacker, what I try to do, I don't want to use the latest browsers. I always want to use an older browser. Why an older browser? Because most new systems are looking for the new browser. Older browser is harder to train against. I now, like with latest version of Chrome, most of your system is geared to understand, and older browser is non-supported browser. Most probably I have not seen that browser before. Most probably I have not studied how to react to it. So I want to look different from a browser. Sometimes, like this is an indication if you're doing risk-based authentication, and we do this, okay? If the browser is too old, it's a flag, because this is how people try to come in and, confuse you, okay? So the point is, you have to do your homework to protect the end consumer. And yes, Rolf?
So it might also be valuable to point out the limits of these device fingerprinting things, right? So most information you get from the device, or actually everything, is public information, right? So if you compare that to knowledge-based authentication, device fingerprinting has a lot of those characteristics, meaning attackers, and they're actually doing it today, will send you to a website and ask your system for exactly that information that they want to know. Yeah. And now they have databases and can start to replay your whatever device fingerprint to the server as well. So these limits are just